All right, here we go. In this particular step, we want to observe the effects of Lenz's law. So, in the circuit above, um, we're going to basically build this, and we're going to have a large inductor. Okay, the neon bulb contains two. Well, this particular bulb, it should contain two electrodes. Okay, in a gas envelope, but we're just going to have a slightly different bulb. Okay, and it won't conduct unless the voltage reaches about 70 volts. So we could still achieve this voltage in this with this simulation. Um, so when the gas conducts, the bulb will glow. So we're expecting to see the bulb glow. So when the switch is closed, DC current in the inductor is determined by the inductor's winding resistance. So we're going to close and open J1 several times to observe the results. So you see J1 there on the diagram, but we're just going to go ahead and build it right now utilizing iCircuit. So I'm going to try to build it the same way that we see on the picture here. And we have our bulb, it's going to be over here. We have our inductor, it's going to be over here. Let me see, do we even need the resistor in this particular case? No. So I'm just going to delete that. We only need one inductor for this particular portion of the experiment. So I'm sliding this over. And then we have our voltage source. This is going to be 12 volts. And it's not enough just to turn the light bulb on. Okay, so I'm just going to call it not enough. Not enough volts. Okay, and then we have our switch, of course, and we have our inductor here. And I'm just going to give that a label. And this is going to be a 70 volts, so I want to make it 70 volts, and hopefully this works. Alrighty, and let's call this just a lamp. It's a substitute lamp. All right, lamp substitute. So we have everything here. We just need to wire this up. Let me put this ground down here as well. So I'm going to go ahead and wire this up. Alrighty, and I guess we can go down here, pull this over here, go down here, like so. Alright, so that's it right there. I'm just going to try to make it a little prettier. It doesn't have to be. Okay, so there we go. And what did we call this one? Let me call this switch. What did they call it? They called it J1. So let's call it J1. Okay. And let's go ahead and close this. And let's see what happens. So you'll see that we have a time constraint, the lower portion. They say at 12 volts, did the bulb come on, okay? And so let's see, at 12 volts, let's just close this junction. All right, and let's see if the lamp will come on. You see how it's on right now? And then it goes off. So basically the phenomena, the idea is that the inductor is trying to maintain the current that's flowing through it. It's trying to maintain its magnetic field. And so if we turn this current on, right now, you don't see anything happening. It's just not enough. I mean, the resistance is high on that other side and all that other good stuff. But if we open this up, current flows. And it's not going to flow through an open an open switch right here. It's going to flow this way to ground. Okay? So it's kicking off a current so that it can maintain its state. And that's pretty much what's happening. Right now, we say, well, did the bulb come on at 12 volts? Well, let's switch it to 6 volts. Think about it. Will this come on at 6 volts? Pause the video for a hot second and then form a preliminary hypothesis and say whether it'll come on, yes or no. I mean, it went down, it came on at 12 volts, and we know that the voltage on this lamp, it requires 70 volts right here, okay? So that's pretty heavy. So let's see. Let's turn this on. Okay, and let me open this up. And it's on again. So let's see what will happen at 3 volts. Okay. Pause the video and just see if you believe that it'll come on. It came on again. And it's actually coming on for a good amount of time. Let's see, 1.5 volts. What do you think? Pause the video again. And it is coming on again. And the time is shortening. Okay? At least that's the phenomena that I'm starting to observe. Let's go ahead and go to 0.75. What do you think? It even came on at 0.75. So let's see what happens at 0.375. Think it'll come on? All right, here we go. And remember, we're trying to open this up. Let's see. It indeed came on for all of these. Wow. So, you know how to answer those questions. I don't think you need to capitalize or anything like that. I believe it's going to be, I'm not sure if it's true or false or yes or no. Maybe I'll indicate it in there a little bit later.